This short section is to review your properties of logarithms. I would encourage you to look at my webpage that's going to send you to some previous lectures on logarithms and exponential functions from college algebra. But let's just look to review our laws of logarithms or properties of logarithms. The first one says that if you have two logs added, you can multiply them together. The second one says if you subtract two logs, you can divide, very much like exponents. This third one, very useful, is that it allows you to move a coefficient as an exponent or vice versa. And these last two come from the idea that if you rewrite this in exponential form, which is the base raised to the power of 0 does equal to 1, and this last one, it says the base raised to the first power equals to the base. And that's how you would rewrite that in exponential form. Also, you should remember that the natural log is the same as log base e. And e is just an irrational number that's approximately equal to 2.718. These last two, really a restatement of this. This says e to the first power is equal to e, and this says e to the x equals e to the x. But what you really want to know is that the natural log and base e really are inverse functions of each other. The exponential function and log function are inverses. But let's concentrate on what you need to know for the calculus that's going to come later, is that you're going to use these properties to expand and simplify these logarithmic expressions. So let's look at this one. We have the log of two things multiplied together. So from that first property, if we look at here, it says we can go backwards. If we have two things multiplied, we can rewrite it with an addition sign. So we can say this is the log of x plus the log of x plus 1 to the fourth power. We've separated it, so that's part of the expansion. But then I want you to look that now we have an exponent. So we're going to go here and we're going to use this third property, and we're going to move this exponent as a coefficient. And that's as far as we can go because we do not have any type of rule that lets us distribute across a parenthesis. That's very important. Let's just look and practice a couple of more. All right, so this time we have division. So that says, the law says we can take the numerator, the log of the numerator, and subtract the log of the denominator. Now that looks almost finished, but as we have spoken before, our square roots are the same as the 1/2 power. So I'm going to rewrite that. And then using law number 3, I'm going to move that exponent down as a coefficient. And one more time, you cannot distribute across a parenthesis. So this would be your final expanded and simplified answer. So let's look at this natural log. It's the same thing, it's just a different base. All right, so again, we've got two things being multiplied together. So I'm going to use property 1 and rewrite this as addition. Now, you're going, what can I do? This is where you need to know that the exponential and logarithmic form undo each other. But let's just go ahead and use that third property and move this down in front. Sorry I wrote that double sign, but I think I'll clear that up in just a minute. Is that the natural log of e is always equal to 1. So I can rewrite this as the natural log of x minus just x squared. Okay, again we have division. So I'm going to take the log of the numerator minus the log of the denominator. All right, I'm going to take this exponent and move it as a coefficient. And I'm going to rewrite this square root as a 1/2 power. Now notice here I have the product. These two things are multiplied together. So I can expand this some more. And look at the mistake that I've already made. This was division, so this needed to be subtraction. All right, so now I'm going to subtract, and now I need to subtract all of this. And that should be plus because we do have a product. And then keep going. Move the 2 in front. Move the half in front. And now I'm going to go ahead and distribute this minus sign. That should be the final answer. So be careful with the signs, all right? Be careful about distributing the minus sign to both of them. And your final answer should be where you have addition and subtraction of logarithms, and what you're taking the log of should not have any exponents.